Okay, here we go. Our next notes, I believe, is section 5, 8.5, properties of trapezoid and kites, 33 through 35 is the page. Okay, so here we go. Let me change it over, and here it is. Properties of trapezoids and kites. The first one is Theorem 8.14. It says a trapezoid is an isosceles. Remember, isosceles has one set of parallel sides. For an isosceles, it says each pair of the base angles, remember base angles, are congruent. And this guy's has two sets. A and D are base angles, as well as B and C, which are adjacent angles. Those are base angles. So to fill us in, it says A would be congruent to angle D, or C would be angle B. These are the base angles of the trapezoid. They are on the parallel sides. Theorem 8.15 is another property of trapezoids that says that it has a pair of congruent base angles. Then that is what can be classified as being isosceles if the base angles are congruent. So here it's saying that angle A is congruent to angle D, or you could say that angle B would be congruent to C. All it takes is one pair of base angles to be congruent, which will force it to be isosceles. Okay, 8.16 says a trapezoid is isosceles if and only if its diagonals are congruent. Okay, so inside an isosceles trapezoid, the diagonals are going to be congruent. Remember, isosceles is indicating that the legs being the sides that are not parallel, are congruent to each other, and that's the markings that it has on the sides, making an isosceles. To fill in the blanks, it has a trapezoid ABCD is isosceles if AB is congruent to CD. Okay. Theorem 8.17 refers to the midsegment. This is something we had back with triangles. We had the midsegment of a triangle. We also have it of a trapezoid. It says the midsegment of trapezoid is parallel to each base, and its length is 1/2 the sum of the lengths of the bases. Now this is the bases, that's the actual line. So I have AB and CD being the bases, and this line in the center is our midsegment. So I'm going to highlight that one. That's our midsegment, and our bases are AB and CD. Notice they are all parallel. Remember, midsegment means it cuts the sides exactly in half. In other words, M is the midpoint and N is the midpoint of those corresponding sides. Filling in the green here for the example, it says MN is the midsegment of the trapezoid ABCD. Then MN is going to be parallel to the top base, which is AB, and it's also parallel to the bottom base, that is CD. Also, the formula, when we put numbers in here, this is going to be half of AB plus CD, and it'll give us our actual measurement. So it's almost like taking the average of the two. Okay, on the next page, 34, okay, this changes to kites, by the way. Okay, remember, a kite is like an actual kite that you fly, also referred to as a diamond, but two adjacent legs are congruent, and the other two adjacent legs are congruent, making it a kite. So it's very, very different than the other quadrilaterals that we've had. Here it says Theorem 8.18, a quadrilateral is a kite if its diagonals are perpendicular. Means they're meeting at right angles, which creates right triangles. And then here, to fill in the green, that means AC is going to be perpendicular to BD. Also, theorem 819 that if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. Only one set of opposite angles are being congruent in this particular setup. So for this, it says that if ABCD is a kite and then BC is congruent to BA, then A is congruent to C and B is not congruent to D. That will not happen in that particular setup. Okay, our examples. Here I plotted the graph here. They could also give you just coordinates that you're looking at, but it says it wants to show that CDEF is a trapezoid. Well, to know that it's a trapezoid means I want to find the slope of my lines and prove that there's actually only one pair of parallel lines. Just one pair. So if I'm looking at it, let's do CD first. I'm going to do the slope formula. And remember, your slope formula was y2 minus y1 over x2 minus x1. So for this first one, I'm taking CD. I'm going to put that small underneath my M. And I'm going to take the y-coordinates. I'm going to do 0, or I'm actually going to do 3 minus 0. And then 1 minus 0. And that gives me a slope of 3. Then I'm going to deal with DE. Slope of DE. I'm going to take my y-coordinate, 4 minus 3, and then 4 minus 1, and that gives me 1 over 3 as my slope. I'm going to take EF. Okay. I'm going to take E from F, so that would be 4 minus 2 over 4 minus 6. Well, that will be 2 over 2, which is a 1. And now I'm going to take the last side, that would be what, CF. And then I'm going to go 2 minus 0, take an F from C. So 2 minus 0, and then the X is a 6 minus 0. Which that's 2 over 6, that reduces to 1/3. Now if I look at all my slopes, I'm looking for anything that's parallel. Well, my parallel ones, if I look closely, I have 2 of them that are parallel. That means DE is parallel to CF, and that's the only set of lines that are parallel, and since I have only one set of sets that are parallel, that makes this a trapezoid. Alright, on example 2, it says a shelf fitting into a cupboard in the corner of the kitchen is an isosceles trapezoid. They want us to find the measures of the other 3 angles given that K is 50 degrees. Notice this is an isosceles trapezoid, so the 2 legs are congruent, which means I have base angles. That means this angle and this angle are base angles, as well as L and M. And when that takes place, they are congruent. So if K is 50 degrees, then the measure of angle N is also 50 degrees. And then do realize that since I have parallel lines cut by a transversal, K and L are supplementary. M and N are also supplementary. So to find L, I'm going to take 180 and subtract the 50 to come out with 130. So L has to be 130, and then that is likewise for M has to be 130, because they have to be congruent bases. Okay. I go to my last page, 35, example 3. They're telling me that MN is a mid-segment, which means it's halfway between. And they want me to find the length of MN. Well, remember, MN is going to be 1/2 of my bases, which would be SP plus PQ. If I fill it in, that's 1/2. SP is 9 plus 16. And 9 plus 16, I believe, is 25. So I want to take half of 25, which is that 12? Oh, well, it's close, not 12, but that is 12.5 is the length of MN. Oh, I forgot my units. Don't forget your units. That'd be 12.5 inches. Mark that bigger over here to the side. Alright, number 4, I'm dealing with a kite. And realize the identifications of a kite is there are no parallel lines. All we have is a congruent adjacent sides, and that's all that they will indicate that it is a kite. Here they want to know the measure of angle T, and notice T is the ones that are across from R, but S and Q are not equal, so that means T and R have to be equal to make this a kite. Well, remember, this is a quadrilateral, so all of this will add to 360 degrees. I know two of my angles are 70 and 88, and then the T and R I don't know, so I'm going to make those X's. I don't know what they are. If I combine these, I believe this is 158 plus 2x is equal to 360. Make sure I added those right. Yes, and I'm going to subtract 158 from 360, and that gives me 202. And that is equal to 2x. Well, that means I have to divide by 2, and x should equal 101 degrees. That means the measure of angle T is 101 degrees for this problem. Realize that also means that R is 101, so both of those are 101 degrees. Okay, here are 4 practice problems that I have placed on here for you to copy down and work. And so you need to pause, copy them down, work it, and then start it again to see if your answers match. Okay. On number 1, it says use example 1 and change point. Well, that's supposed to be point. I forgot my T on the word point. E to 7.5 or 7.5, and then what type of quadrilateral is it? So I'm going to go back to that example. And they said E is going to change to 7.5. 1, 2, 3, 4, 5, 6. So 7 would be out here, and 1, 2, 3, 4, 5 would be up here. So 7.5 would be my new coordinate for that particular problem. Well, if I'm imagining that E is not here, but extending out and coming down in that particular fashion, now it looks like a parallelogram. I already know that DE is parallel to CF, so now I want to check to see if CD and the new FE will be parallel. So I'm going to do the slope of EF now. I'm going to have 5 and a 2 for my Y's, and 7 and 6 for my X's. 5 minus 2 is 3 over 1, so that means the slope of EF is 3. The slope of DC, or CD, on example 1 was 3 as well. Both of those were 3. And since we had parallel sides, EF is parallel to CD, and then on the front one we had DE is parallel to CF. We have 2 sets of lines that were parallel. That makes this a parallelogram, no longer a trapezoid, because it has 2 sets of lines that are parallel. If I'm also looking at it, I need to realize that D to F, that means those sides are actually congruent to each other. I was going to go somewhere else, but that is a parallelogram, and that's all I can say about it. I know they're not, it's not a rectangle, because this is not a right angle here. Alright, on example 2, B is 135. That means C is 135 degrees. Oops, I forgot my C in there. And I don't know what happened to my whiteout. So measure of angle C equals 135. Measure of angle A and the measure of angle D will equal, but they're supplementary. So I want to take 180 and subtract 135 to find out that the other angles are 45 degrees. On number 3, LMN is the mid-segment. So to find LMN, I'm going to take 1/2 of my bases, so that'd be 30 plus 12. So I'm going to take half of 42, and that tells me that LN is equal to 21. Oh, I forgot my units again. Don't forget your units, that's feet. On example 4, two of my angles, I have 75 and 85, so I'm going to take 75 plus 85, and then I'm going to make my G and I at X's has to equal 360 degrees. 75 plus 85 is 160, plus 2x is equal to 360. If I subtract 160, that gives me 200, and 2x divided by 2, that tells me that x is 100. That means measure of angle G is 100 degrees. Alright, if you got these problems right, I'm going to do a thumb again. Here we go. There's my nails, my little finger. And then here we go with my thumb. Give yourself a thumbs up for doing an awesome job. And if you don't like the thumb, of course, you can do a big old smiley face for this problem.